Assalamualaikum warahmatullahi wabarakatuh and a very good day. My name is Nur Imam Maisara binti Kamar Zaman and I am the leader for this week. My group members are Farisha Nalia Zainal, Arif Imran bin Ikwan Surazi and Amalia Pemata Aminuddin. So in this video, we will be presenting our lab report for experiment 3, which is application of first and second law of thermodynamics. Firstly, I will share and explain each member's task. So in this experiment, my task is to compile all slides, do cover page and also discussion. Next, Amalia Permata is in charge for the objective, introduction, and also result. Farisha Nailia is in charge with theory and methodology. And lastly, Arif Imran is in charge for abstract, conclusion, and video compiling.
So now I'm going to talk about abstract. The reason this experiment conducted was to apply the first law of thermodynamics and the concept of the second law of thermodynamics in a process. Two beakers were used in this experiment where there are cold water and hot water. Both temperature of water were recorded, and then the hot water beaker was placed inside the cold water beaker. The reading for both beakers were recorded every 1 minute until thermal equilibrium achieved. After that, the graph for water temperature for both cold and hot water were plotted.
For the objective of this experiment is to apply the first law of thermodynamics and the concept of the second law of thermodynamics. For the introduction, the first law of thermodynamics is also known as the conservation of energy principle. It concerns with the conversion of energy from one form to another form, and heat is one of the form of energy. It concludes that the heat energy cannot be created or destroyed. However, it can only be changed or converted from one form to another forms of energy and transferred to one location to another location. For example, the conversion from sunlight as the light energy into the leaf as chemical energy in photosynthesis. The second law of thermodynamics is about the quality of energy and the directionality of the process. Energy has quality as well as quantity, and actual process occur in a certain direction, not in just any direction. For example, heat flows from higher temperature along with high energy level to lower temperature with low energy level.
Hi, Assalamualaikum. My name is Farisha Zainal and I'll be presenting the theory of this experiment. So first law of thermodynamics states that energy is always conserved as it cannot be destroyed nor created, while energy balance is the relationship between energy input and energy output. Energy balance, or first law of thermodynamics, is often used to calculate the heat transfer of a system. As an addition, second law of thermodynamics for closest statement states heat cannot flow from cold body to hot body without any work input. Thus, if the heat flows from hot body to cold body, then no work input is needed. Next, the energy balance equation of the system that may be used in this experiment. So En minus E out is equal to E system. Delta U system equal to 0, where delta U system equal to delta U hot water plus delta U cold water equal to 0. MC T2 minus T1 hot water plus MC T2 minus T1 cold water is equal to 0, where M is a mass in kilogram, Cp is a heat capacity in kilojoule per kilogram Kelvin, where T is equal to temperature in Kelvin, and delta U is an internal energy. Next, we're going to move to the methodology, where the apparatus that we needed in this experiment is kettle, small beaker, stopwatch, balance, big container, and thermometers. So the first step, the water was heated using kettle, and the second step, the empty beaker was weighed while waiting for the water to boil. And step 3, the small beaker was filled with hot water and the weight of the hot water was recorded. And step 4, the small beaker was placed in the big container carefully. Step 5, the big container was filled with cold water until it reached the same level with the hot water in the small beaker. The cold water was weighed after this. In filling the cold water in the big container, we must ensure that the cold water is not getting into the small beaker where it contained of the hot water. So step 6, thermometers were set. One was placed in the small beaker and the other one was in the big container. And the last step required in this experiment is the readings for both water was recorded in the table provided for every 1 minute interval using the stopwatch until thermal equilibrium was achieved. That's all for me. I'll pass to my other members to present the other part of this lab report. Thank you.
Next is for the result. There's the data given, which is heat capacity of water, Cp, with the value of 4.187 kg, and mass of hot water used, M, with the value of 0.203, and mass of hot water used, which is 0.730. Before we go through the question, this is the table 1, which is temperature of hot and cold water for every 1 minute from 0 minutes to 20 minutes. There's the temperature difference for hot water and cold water that we can get from the T minus T0. The second table, which is energy difference for hot and cold water, kg, from 0 minute to 20 minutes. There's also the energy change that we get from add the energy difference for hot water and energy difference for cold water. First one, plot the graph of water temperature versus time for both the hot and cold water. State the equation of graph obtained using the curve fitting method. So this is the graph that we obtained from the data, which is graph of temperature of hot and cold water against time. The blue one is for hot water temperature and the orange one is cold water temperature. So calculate the energy change for both the hot and cold water. So for energy change for hot water, we use the formula of m hot Cp T2 minus T1 hot. And don't forget to change the temperature from Celsius to Kelvin with plus with the 273, and then we can get the value of negative 12.749 kg or 12,000. And then for energy change for cold water, we use the same formula as change for hot water. M cold Cp T2 minus T1 cold. So we just change the M hot with M cold and T hot with T cold. And for the temperature, we also don't forget to change it to the Kelvin with plus with 273, and then we can get the value of 3056 kg. So for the total, we just add the energy change for hot water and energy change for cold water. So for the total, we can get the value of negative 9693 kg.
For the discussion, we had discussed two things. Firstly, the observations during the experimental conducted. The temperature of hot water decreases, meanwhile temperature of cold water increases for every 1 minute interval. Then, both hot and cold water reaches about the same temperature, which is 36 degrees Celsius for hot water and 35 degrees Celsius for cold water after 20 minutes. This shows that the first law of thermodynamics is applied, where heat transfers between hot water and cold water until it reaches equilibrium. Next is to compare the changes in energy for both the hot water and cold water and relate it with the second law of thermodynamics. So for hot water, energy change for 20 minutes is negative 41.648 kilojoule. The negative sign shows that it is an exothermic process where heat energy is released from hot water to cold water. And for cold water, energy change for 20 minutes is 21.392 kilojoule. The positive sign shows that it is an endothermic process where heat energy is absorbed by cold water. The heat transfer between hot water and cold water indicates the second law of thermodynamics is being applied, where heat flows only from high temperature body to a low temperature body. The energy changes for both hot and cold water does not equal to zero due to some energy lost to the surrounding. This can be caused by an excessive amount of energy released by hot water not being fully absorbed by the cold water. Therefore, volume of cold water should be added more so it can absorb more energy.
Lastly, for the conclusion. In conclusion, after we done this experiment, it can be proved that first and second law of thermodynamics are valid. In the graph, we can see that the water reached its equilibrium temperature at 90 to 20 minutes. It also shows that the rate of heat transfer proportional to rate of temperature change. The temperature change for hot water was negative 49 Kelvin and the energy change is negative 41.6481 kJ. The negative value indicates that the temperature decreased and energy being released. The temperature change for cold water was 7 Kelvin and the energy change is positive 21.3956 closer. The positive value indicates that the temperature increased as energy being accepted. The result from the experiment may be different from the actual. This was due to error that occurred when conducting the experiment.